Welcome to my channel. In this video, let's discuss about nested loops. When you have one or more loops inside a loop, we call it as a nested loop. It could be a while inside a while, or a for inside a for, or a while inside a for, or you could even use a do-while loop. It is also possible to nest three loops like this. Let's take this example. Say you want to print 5 stars like this. You just have to run the loop 5 times and print star. Let's use the loop variable as j here. For j equal to 1, j less than or equal to 5, j plus plus, printf star. So now 5 stars get printed in the output. Say you want to print 5 sets like this. With this code you will get only one row printed in the output. So you want this itself to be repeated 5 times, which means that this entire code has to be repeated 5 times. In order to do that, we have to enclose this code inside a loop. For, now let's use I equal to 1, I less than or equal to 5 because you want 5 rows, I plus plus. Now we have enclosed this block of code within a loop. This will not give the correct output because nowhere we mentioned about moving to the next line. After printing 5 stars, you should have a next line character, only then the cursor moves to the next line in the output. Each time the inner loop gives us 5 stars. So after completing the inner loop, here we have to give one more printf to print the next line character. We know that this inner loop gets executed 5 times. The outer loop also gets executed 5 times. But the point here is that during each iteration of the outer loop, the inner loop gets executed 5 times. Let's see how that happens. When the execution begins from the outer loop, initially the value of I will be 1. When the execution of the inner loop begins, the value of j is 1. Printf will be executed and a star will be printed in the output. Then the value of j becomes 2 and another star gets printed. And then it becomes 3 and one more star gets printed, and then 4 and then 5. It also becomes 6, but then the condition fails and the execution of the inner loop comes to an end. So here this printf will be executed and the cursor will be moved to the next line. Now the value of I is 1 and the execution comes here to increment the value of I and I becomes 2. Now again the execution of the inner loop begins. The value of j again starts with 1 and changes to 2, 3, 4, 5 and 6 and 5 stars are printed on the output. Then again the cursor moves to the next line. Now the outer loop continues to execute. I becomes 3, the condition is still true. The inner loop runs for 5 times and 5 stars are printed. Similarly I becomes 4 and 5. And finally when I becomes 6, the condition here fails and the execution of the outer loop comes to an end and we have the desired output. So the logic is simple. Each loop does its own job. This loop is getting executed 5 times. Since we have one more loop inside, during each iteration of the outer loop, the inner loop gets executed 5 times. So actually here the inner loop is getting executed 25 times. This is just a simple example to show how nested loops work. You can write a very simple program to print the exact same output just by using a single loop. I will leave it to you to think about it. This is the prime number program that we discussed in the previous video. This program takes an input number n and tells whether it is prime or not. Say for instance you want to write a program to list out all the prime numbers less than the input number. For example, if the user enters 100, you want to print all the prime numbers less than 100. This program, which already contains a loop, can only check if a single number is prime or not. So you have to put this entire logic inside another loop which will vary from 1 until 100. In order to change this program, let's declare one more variable called input, and of course you have to scan the input. After that, now we have to write one more loop. What is a loop variable here? This loop takes the value of n and evaluates it. Now we need to vary n from 1 until 100. Instead of 1, let's start with 2 because we know that 1 is neither prime nor composite. So for n equal to 2, n less than or equal to the input value n plus plus. So this entire logic goes within the outer loop so that we can check if each of the n is prime or not. Here we have to change a little bit. We don't want this part. If is prime is 1, instead of printing prime, we have to print the number itself. So that's it. Let's check whether our program works. Let's run it and enter the number 100. We get the output as 213. Obviously, the program doesn't work. What's the problem here? Here we have initialized is prime to 1 in our previous program. Is prime has to be set to 1 before checking whether a number is prime or not. It is getting modified inside the loop. So when the loop runs for the subsequent numbers, the value of is prime might have changed. The initialization has to be done before checking each numbers. So let's run it again and add 100. This time our program runs properly, giving the desired output. Let's write a program to sort an array of numbers. Say this is an input array A. You don't have to know any kind of sorting algorithm for this. Just think on your own as how to sort these numbers. Any basic logic that you can think of will require nested loop. Let's take the number in the first position and compare with each and every other number in the array. If we are able to find a smaller number than the first number, then swap those two numbers. Because we want the smallest number to be present in the first position, right? So now the array becomes 2, 8, 5, 1, 3, 6. Continue doing the same thing. We have compared the first number with these two. Now compare with this position. Again you have to swap one more time as 1 is lesser than 2. Now when you compare the first element with the remaining elements in the array, there will be no more swaps because 1 is the smallest element of the array and we have placed that in the first position. Now we are done with the first position. Let's do the same thing with the remaining numbers. Take the second number and compare with each and every other number and make a swap if necessary. By doing so, you will get the next smallest number in the second position and you can repeat the same thing till the end of the array. And finally, you will be having the sorted array. Here there are two steps. First, you are selecting one particular position and comparing the number in that position to the subsequent numbers in the array. First, you have to select the 0th position and then the first position and then the second position and so on. So you need a loop for selecting the position of the array. Let the loop variable be I. You should start I with 0. And you should proceed until the end of the array, which is size minus 1. Once you have selected a position, you should compare the number in that position to all the subsequent numbers. If you have selected the 0th position, you should start with the first number. If you have selected the first position, you should start with the second number. So basically, you need another loop which runs from I plus 1 because I denotes the position here until the end of the array. You should compare all the elements till the end of the array. So you have to run the loop until size minus 1. Let's now write the program for I equal to starting with 0, I less than size of the array, I plus plus. You have to increment one element at a time. So it's I plus plus. This loop is going to help us decide the position of the element. So at any point of time, A of I denotes the element in the position to which you are going to compare all the other numbers. So the next loop is for j equal to start with I plus 1, j less than size, j plus plus, because you need to compare all the subsequent numbers. So increment one by one. So now we are going to compare A of I with A of j. If A of I is greater than A of j, the number in the position that we have selected is greater than the subsequent number, which is incorrect because we want to bring the small number to the front. So we have to make a swap here. Let's just use a temporary variable and store the value of a of I in the temporary variable. So the value of a of I is safe now, so it can be replaced with a of j. Now a of j can be replaced with the initial value of a of I, which is in the temporary variable now. So that's it. This is the logic to sort an array. If you run the program, I have declared an array of size 20, asking the user to enter the size and scanning those many number of elements, and then the logic that we discussed, finally printing the output array. So I have tested by entering 4 numbers and we can see the sorted output. This logic that we wrote for sorting is known as selection sort. It is one of the worst algorithm that you could write for sorting, but the algorithm doesn't matter when the input size is very small. The time difference between the best and the worst algorithms is negligible for small inputs, so it's fine as long as our algorithm works. Let's now write a program for matrix multiplication. I have chosen this program because it involves 3 loops. Let's quickly see how to multiply 2 matrices. Let's take the numbers 2, 3, 5, 4, 1, 6 and multiply it with another matrix 2, 1, 3, 4, 1, 8. Say this is matrix A and this is matrix B and we are going to multiply it. First you have to take the first row of matrix A and multiply that with the first column of matrix B. You should multiply 2 with 2 and then 3 with 3 and then 5 with 1 and then add the results. So it is 2 into 2 plus 3 into 3 plus 5 into 1. So when you compute this expression, you will have the first element of the resultant array, which is C. Now let the first row be here as such, but let's take the second column in matrix B instead of first. Again you have to do the same corresponding multiplication and then addition. So it's 2 into 1 plus 3 into 4 plus 5 into 8. Now we have done with the first row, you have to move to the second row. Multiply the second row with the first column. 4 into 2 plus 1 into 3 plus 6 into 1. And now move to the second column here. So this is the resultant matrix. Here A is a 2 cross 3 matrix because it has 2 rows and 3 columns. Similarly B is 3 cross 2 matrix because it has 3 rows and 2 columns. You can see that C is a 2 cross 2 matrix. Whenever you are multiplying, you are taking one row at a time from matrix A and one column at a time from matrix B. When you are taking one row at a time, you are moving through the columns here. Similarly, here you are traveling through the rows. Since you have to multiply the corresponding elements and add, the number of columns in the first matrix should match the number of rows in the second matrix. Only then it is possible to multiply the two matrices. Otherwise, you cannot multiply the matrices at all. Let's say M and N denotes the number of rows and columns of matrix A. Similarly, P and Q denotes the number of rows and columns of matrix B. So the condition here is that N should be equal to P. If N is not equal to P, it is impossible to multiply those two matrices. Now let's write the program. First we have to scan matrix A, that is get the input elements of matrix A. So first we should ask for the user to enter the number of rows and columns and scan M and N, which we can do very easily. And then we have to get the elements of the first matrix. As it is a two-dimensional array, this denotes the 0, 0 element. This is 0, 1 and this is 0, 2. Here the 0 represents the row and 0, 1, 2 represents the columns. Similarly, this is 1, 0, 1, 1 and 1, 2. So in order to scan these elements, you need two loops for I equal to 0, I less than the number of rows, which is M, I plus plus, and J is for traveling through the column, so J less than N, J plus plus, and you have to get the input value from the user and store it in the array. The position is I, J. So by doing so, you will be able to scan all the elements of the first matrix. Similarly, you have to change the logic for scanning the second matrix by changing M to P and N to Q and here A to B. Now that we have scanned the two matrices, let's get to the main logic. So let's generalize what we are doing. First, we are taking one row at a time from matrix A, and for each of those rows, we have to multiply by taking one column at a time from matrix B. First, we are taking one row at a time from matrix A. For each of those rows, we are multiplying with all the columns in matrix B. So the outermost loop should be able to loop through all the rows in matrix A. For I equal to starting with the 0th row, and you have to scan all the rows in matrix A. The total number of rows in matrix A is M. So I less than M, I plus plus. Now for each of the row you have to multiply with each column in matrix B. The first row should be multiplied with first and then second column, and then the second row should be multiplied with first and second column. So that is why we are going to write a loop within a loop. Now this loop should be able to travel through the columns in matrix B. So it's for j equal to 0. The number of columns in matrix B is Q. So j less than Q, j plus plus. As I mentioned in the beginning, this program requires 3 loops. So why do you need the third loop for? Is it for finding the position of the resultant element? Let's see. This is the 0, 0 element of the result. It is found by multiplying the 0th row of A and 0th column of B. This is the element 0, 1. It is found by multiplying the 0th row of A with the first column of B. Similarly, this is 1, 0, which is found by multiplying the first row of A with the 0th column, and this is 1, 1, which is got by multiplying the first row of A with the first column of B. So the index of the result is very easy to find. It is just C of I, J. You don't need a third variable for that. But in order to find C of ij, we need to multiply the corresponding elements, right? Here I refers to the row of A, and similarly j here refers to the column of B. But in order to access each of these elements, you need to know both the row and column number of A. Same applies to accessing the elements of B. So you have got the row number with the help of I. In order to find the column of A, k equal to 0, k less than, we are talking about column of A, right? Which means we have to proceed until n, k plus plus. But we also have to access the elements of B. Here with J we only know the column of B. What about the rows of B? The rows of B should start from 0 until P. Since N and P are equal, we can use this same variable for the column of A and row of B. Let's write the code, you will understand it better. C of ij is nothing but, in order to access the element of A, we know that it is A of I, and the column can be found with the help of K into B of, the row of B can be again found with the help of K, and the column using J. Here this helps us to only multiply one of the elements. We have to accumulate the product. While calculating the second product, we have to add it to the previous result. We can use the shorthand operator here, but you have to make sure that C of ij is initialized every time. We have to initialize it here. Here instead of n, you can also use p because n is equal to p. I will leave the link for the complete program in the description box below. The best way to gain expertise in nested loops is to practice a lot of pattern printing like this. Thank you for listening.